Today we're going to be looking at Chapter 3, Day 1, definition of a function. And right off the bat, we get some vocabulary here that should be familiar to you. And the domain, if you remember, is the set of possible input values. Now, typically, these are your x's, but not always, as you'll see in just a minute. Sometimes they're t's. It just depends on the particular function we're talking about. The range, if you remember, is the set of possible output values. And again, usually we use y's, but not always. Sometimes they're going to be something else. You got to make sure, again, you're looking at your functions carefully. All right. So the next thing we're going to take a look at to start the chapter here is different types of equations. All right. These are called parent equations. These are ones that you just need to go through and memorize because you will be asked to do a lot of stuff with them this chapter and the rest of the year. Okay. So if we take a look at, and I like to do the graph part first. So if we look at linear, well, linear is pretty straightforward. That just goes through the origin, diagonal line with the slope of 1. And we know the domain, because it goes left and right forever, we're going to do all these in interval notation. We would say the domain, all the possible x's are from negative infinity to infinity. All real numbers, but make sure you write interval notation, avoid losing silly points, and the range goes up and down forever, so we know that we're going to go negative infinity to positive infinity, right? There's just our basic linear equation. There's our information for the domain and range, and you notice you want to add constant slope, things like that. You're more than welcome to get that last column. You can put whatever you want in there. Okay, absolute value. Same thing, it goes through 0, 0, but absolute values are v's. All right, and we know that the domain, as you can see, goes from left and right forever, so negative infinity to infinity. But the range starts at 0, right? Remember, range is the lowest y, and you work your way up. So we know that we start at 0 to infinity. And as you can see, I put the bracket on 0 because we are including that point, right? Infinities always have parentheses, but if you include a value, you got to make sure you put a bracket on it. So we get the bracket on the 0. Similarly, with the quadratic or the parabola, right? It goes left and right forever. So all real numbers, negative infinity to infinity for domain. But the range starts at 0, goes up forever, bracket on the 0, parenthesis on infinities like always. All right, cubics. Cubics look like that. Again, goes through 0, 0. Just the basic y equals x cubed. Our domain is, again, negative infinity to infinity. Our range is also up and down forever, negative infinity to infinity. Okay, rational. Now we're going to get to a little bit more interesting functions. We know that the rational graph, if you remember, we cannot have 0 in the denominator. So therefore, x can't be 0. So you have a vertical, right? You have a vertical asymptote. There's a little note there for you, vertical asymptote. You also, in this case, get a horizontal asymptote. The abbreviation right there to make it fit in that box. So we have that. And what the graph looks like, it actually has 2 pieces because of that vertical asymptote. And it just goes really close to that vertical and horizontal asymptotes at x equals 0 and y equals 0 in this instance. So my domain actually has 2 pieces because of that break. Goes from negative infinity until 0. Now, in this case, I do not include the 0. So I'm purposely putting a parenthesis there because we are not including it. It's not like previously we had brackets because we wanted it. Do not include it because it does not include it. Union 0 to infinity. Again, avoid silly points because you put a bracket on that 0. That would be wrong. You got to make sure you put parentheses because we're not including the 0. And the range is the exact same thing. You start at the bottom, you work your way up, you hit 0, not including because the horizontal asymptote in this instance is going through there. You never get y equals 0 in this case. They have a break, and then it goes up forever. So we're going to say union 0 to infinity. I guess I needed a bigger box. All right, so hopefully we're able to fit everything in there. Okay, square root. Well, that's a graph that just starts at 0, 0, and it goes up forever. It takes a little while to go up there, but it does keep going in an arc, not a straight line. It's an arc. And we know that we're going to start at 0, and we're going to go to the right forever. Just like our range, our lowest y value is 0, and it goes up forever. Okay, so those are the same in that instance. And last but not least, we got a cube root function. if you may remember, that looks just like or very similar to the square root, but you also have the piece that goes to the left forever. And that does go up and down forever. So we go left and right, negative infinity to infinity. And again, we're going up and down. It's an infinity sign. Here we go. And then we are going up and down forever. Mine looks like it flattens out, but it flattens out, but it keeps on going. Okay, so make sure you realize it does go up and down forever in those. All right, so those are the ones that you just need to memorize, because we will the next few days manipulate those. We'll look at domain and range today, but we are going to manipulate those in the next few days. So you do need to know the basic parent functions that we are talking about over here. Okay, memorize domain, range, what they look like especially, and what the equation is that goes with it. Okay, so let's take a look at these. Well, part A is an f of t function. It has t squared, so you can recognize that it's a parabola or quadratic. So since it goes up and down forever, but we're only looking at the domain, it goes left and right forever. That simply is just negative infinity and to infinity, right? Because it goes left and right forever. That's a pretty straightforward, easy one. The other terms are just making it shift and move, but you don't need to worry about that. All you have is the domain. Okay, here's where it gets trickier now. Now we're looking at a rational function, right? And we talked about that up here. And we look at the rational function, it's when the denominator equals 0 is the problem. So what we want to do is we want to figure out, okay, well then I want to know when t squared minus 8t plus 15, I want to know when that can't be 0, because I'm taking a look at when the denominator cannot be 0, because that's what causes the vertical asymptotes. So in looking at that, if I were to go through and solve this, well, that's just some easy algebra, right? You got to do a little factoring. I have t minus 5 and t minus 3. I know those can't be 0. So I know that t cannot be 5 or 3. So that's a great answer. T cannot be those values, but we have to put it into interval notation with the parentheses and brackets. But we want to say everything is possible except 5 and 3. So you say, well, how do you do that? Well, we want to start at negative infinity, and we're going to go up until 3, because that would come first on the number line, right? If you think about this on a number line, right? We're saying here is 3. We can't have 3. We can't have 5. So we want to say everything here. Well, that's just negative infinity to 3, right? Parenthesis, because we have open circles. Union, well, everything between 3 and 5 is okay. So we're going to again say parenthesis 3 to 5, and then not including the 5, and then everything after is okay. And we're going to say 5 to infinity. Got close on room there. And that is your domain. So basically we're looking at what makes the denominator 0, because we do not want to include those. In this instance, it was 3 and 5. So we say, okay, we can't have 3 and 5. So therefore, those are where the breaks occur and the union symbols come out, because you have 3 different parts. Okay, and look, it's all parentheses, no brackets in there. All right, now we get a little bit trickier. So now we're taking a look at a square root. Okay, well, if you remember square roots, you want to take what's on the inside, minus 8t plus 15. And we want to know when that's greater than or equal to 0. That's what we're looking at. That's the way the square roots work. It takes whatever's inside, and you have to make that greater than or equal to 0. Okay? Well, we already figured out that our breaks occur at 3 and 5. And so if you recall from previous years of doing a sign chart, this is where you may want to go through and say, all right, well, we know that I have 3 and I have 5, because if I plug those in, I get zeros at those particular values. And you can go through if you wanted to. You can make a sign chart. This is where you could plug in values. If you did this in algebra last year, you could plug in values less than 3, right? Plug some in right into this equation, and you would see that you get positive values. If you plug in numbers between 3 and 5, like 4, for instance, you would see that you get a negative value. And then if you plug in a number greater than 5, like 10, pick a big number, make it obvious. Plug in a big number, you're going to get a positive number. And so you can see that everything to the left of 3 gives us positive, which is what we want. That's what this is saying here. This is saying we want to look at where are all the positive values. Oh, look, here's where I see a positive value. So that means that it would occur from negative infinity to 3, bracket, because we are including it, right? We have a closed circle there because it's greater than or equal to. So we have that. And we also want to say, well, it's also here greater than 5. So union 5 to infinity. And this would be the domain of that square root. Okay. Now, what I've also seen before, and I think is actually an easier way, if it's a nice, easy parent function, you've memorized your graphs. What I can actually do for this is I can actually go through and just, if I know where the zeros are of that quadratic that's been shifted, is I can actually look and make that graph. And then look at, oh, it was positive when it's above the x-axis. It's positive when it's above the x-axis. That's a quick way than plugging in numbers to get a sign chart, I think. And then you get the exact same answers when you look at where's the graph above the x-axis. So if you know your parent functions from above and you know things like, oh, this has zeros at 3 and 5, you can just draw a nice quadratic. It's got a positive t squared. You could draw that in there, and then you can just say, well, those are my positive regions because those are above the x-axis, and that would be my possible domain. If you don't know that, you can always go back to the sign charts and do, okay, here's positive, there's negative, there's positive, and then you get the exact same answer. So it's kind of a comfort thing. I think the graphing is quicker if you know your graphs, but it's up to you if you know those and you practice those. Okay. Now the last one, well, that one's really easy. We said if it's a cube root, that means that the domain is going to always be all reals. So there we go. There's just some practicing of domain. You got a quadratic in letter A, you got a rational in letter B, you got a square root in letter C, and you got a cube root in letter D. So practicing all our different functions in there. Okay. Now we got to find the domain or range of here. Again, just like we did above, to find the domain, we're looking at when the denominator cannot, oops, I'm going to say cannot be 0. Well, that's easy. So we just know that x can't be 0. So our domain is everything but 0. So negative infinity to 0, parenthesis, union 0 to infinity. That was pretty easy. Okay, so there we got the domain part. All right, do a different color and get the range here. So looking at my range, well, I want to find my vertical asymptote if there is one, right? Actually, not vertical. I'm just kidding. I want to find my horizontal asymptote. And so you may have looked at, gone through and figured out, or recalled from last year, if the degree on top and the bottom are the same, we look at a ratio of the coefficients. So what we know then is that y is not going to be -1 over 1. I'm just looking at a ratio of the coefficients right there. So I know that my range is everything but -1 and 1. So I know that I'm going to have from negative infinity until -1, union -1 to infinity. Okay, and that's going to be my range for this graph. Now, range can be difficult sometimes. Some of you are like, whoa, that was pretty fast. Try that. See what we just did with the ratio of the coefficients as you're going through when they're the same degree. We'll get into that more later in chapters. What you can also do, if it's a calculator question, or right now, what I would do is try it by hand and then go to your calculator and then type in what you see. Oh, let's get crazier. Let's go alpha y equals. Let's put a fraction in there. So I have 1 minus, and the x button is right there. Drop it down to the denominator. I got an X button, right? What I want to do, if I were to just hit zoom 6, because you may have been playing with your calculator before, the window might be all crazy. So hit zoom 6, and that kind of sets it up. And you can see, there you go, right there, you can see at x equals 0, there was our vertical asymptote, right? If I hit trace, and I can see at x equals 0, I have y equals nothing, because I have a vertical asymptote that's going right there. If I had a horizontal asymptote, well, if you look at it, there's a horizontal asymptote at y equals -1. See, if I hit trace, if I go to the right a bunch of times, right, you're going to see it's going to get really close to -1, but it will never actually be -1. Okay, and so you can keep on going forever. And if I was in class right now, I would show you on my screen, on my awesome TV screen, that it never hits -1, and we would go forever in the thousands, but we don't have time for that. Okay, so that's why I know the range is everything, because it goes below -1. So it's everything until you get to -1. Then there's a break, and then it's everything above -1. Okay, so there's our domain or range. Those range get a little tricky, so sometimes it may be helpful to graph it on the calculator afterwards. Just double check you did it right. Okay, because it's a non-calculator question, you got to practice that. All right, okay, here we go. Let's take a look at the second page. All right, on the second page, scoot this to the top. All right, So we look at this. We got evaluating functions right here. And they're showing you, for example, f of x equals 4x minus 3, g of x is x squared minus 3. The input, right, we'll go back to our there. The input is what's inside. That's just way to read proper notation. So whatever number's on the inside of the parentheses, that is your input. That is typically your x value, right? We've been doing x's so far. All right. Or not so far. We're going to look at them right now by looking at these problems. My output is whatever's on the outside. Okay, that is usually your y value. We talked about that in the beginning, right? So your input, looking at the domain, the output, looking at the range. Okay, so here's an example of two particular functions that we're going to look at. We're just going to evaluate. So we got a difference here. We're not asking for what's the domain. We're not asking for what's the range. We're asking to evaluate. We're asking for simply just to take the value that's in the parentheses and substitute it into the equation. Make sure you pick the correct equation. So if I look over here, I get f of 1. Well, I can see that's right there. I know that it's 4 minus 3. I'm just going to replace the x with a 1 because on the inside, that is my input that I have there. So it means all I'm doing is I'm plugging that value into the x right there. And then if I were to simplify this, 4 minus 3 just gives me a value of 1. So when my input is 1, my output in this particular instance is also 1. That does not always happen. That's just a coincidence right there, okay? All right, let's look at letter B. Same thing. If I were to go through, and I'm just going to substitute 2 square root of 2 in for x. That's what I'm doing is my input is 2 radical 2. So if I clean this up, not really much you can do because you got unlike terms, but you can multiply the 3 and the 2. And I'm going to get that as my output, 4 minus 6 radical 2. Okay, same thing with letter C. They're saying now we're going to replace the x with the absolute value of x plus 1. So simply, I'm just going to just do 4 minus 3 times the absolute value of x plus 1. I'm just plugging in the absolute value of x plus 1 for x. There's nothing I can do at this point, right? I can't simplify, do not distribute, do something goofy or silly like that. That is your answer, and you cannot do any more, okay? So there we go. All right, if you take a look at letter D, we want to know in letter D, all right, oops, that got cut off. We're going to come back to that in just a minute. That actually is letter F. Okay, we'll look at letter D right now. So we're saying f of x plus 1 over 2. Well, if I go through and I substitute that in there, I got 4 minus 3 times the quantity of x plus 1, over 2. So if I were to go through, because you can simplify, you should. So if I were to do this a little bit, well, what I probably would do is I would do 4 minus, I would take out the halves and quantity x plus 1. I think it's a little bit easier algebra to do it that way. And then I can say 4, if I distribute, I have negative 3 halves x minus 3 halves. And you're all going to be very careful with combining your like terms. You got fractions, right? Make the 4 8 halves if that helps. Either way, you should get 5 halves minus 3 halves x. And there is my output when I plug in x plus 1 divided by 2. All right, letter E, we're going to switch it up a little bit. Now we're going to use the quadratic g of x equation. So I'm going to go through and say, all right, I'm just going to make sure you're using the g of x now. All right, so I'm just going to plug in x plus 1 squared into the x value, into the input, okay, because it's always telling me, it's just notation. It's telling me whatever's inside the parenthesis, that replaces whatever the x's were in the equation. Now I want to go through and simply just clean this up. So in order to clean this up, this is where you have a quadratic squared, not quadratic, a binomial squared. So if you need to, write it out twice, multiply it out. Some of you have practiced enough where you're going to say, oh, that just means x squared plus 2x plus 1, right? If you need to off to the side, write this out twice and distribute or FOIL, whatever. That's all that means, okay? So if I read twice, I got that. I still have the minus 3 there, so I'm going to combine like terms and say x squared plus 2x minus 2, and that is the output that I get when I go through and solve these, okay? Now, one thing I want you to notice in both of these, after I finish simplifying it, that is my answer. I've seen silly kids over the years make it equal 0 and then solve for x. Like, what are you doing? Don't be that kid. Stop right there. That's all it's asking for. What's the output when you plug in x plus 1 in this instance? That's you get. Your answer is this: x squared plus 2x minus 2. Do not make it equal to 0. If you do that, that's a very bad choice. You're going to lose points in your quiz and test. You've been warned. All right. Now, actually, letter F was what it was typed in over there. Must have got moved. I want to know what is x when g of x equals 2. So that's actually got typed on over there, got moved over there, but just fill it in for letter F. So all I'm asking, we're switching gears now. Now I know what the output is. I know that my output is 2. So I'm asking, what's the input? Okay, so I take my g of x, that's the equation we're doing. So I'm just going to let x squared minus 3, I'm going to make it equal to 2 because that's what's asking. It's saying what is x when your function comes out to give you 2 as your value? That's what's asking for. Okay, so we're switching gears a little bit here. Hopefully you caught that and you're like, no problem. So now I just got to solve this. This is one where I have to solve because I know the ending. Now I got to figure out what's the beginning, the inside, what got substituted in. That's what I'm looking for. So I add the 3. X squared equals 5. I'm going to take the square root. And of course, you are going to be awesome and you're going to put plus or minus square root of 5 because you remember that quadratics have 2 possible answers for that. Okay, and that is the input. All we're saying is we got the input. That is when you go through and do solving, not letter D, not letter E, because that was just asking what is the final output answer. Okay, boom, there we go, we got it. All right, here we go. Similar idea. Given that g of x, we got a new equation here, 3x squared minus 5x plus k. Find a non-zero k such that g of k equals k. All right, so what is this telling me? Well, this is saying when your input is k, your output is also k. So you want to try this on your own, see what you come up with, hit pause right here, and then come back, and we'll talk about it together. So you want to try it? Otherwise, here we go. The input is k. So that just means replace all the x's with k's. So I have 3 k squared. I might put the parentheses in there. That's okay. Minus 5. I'm going to replace that x with a k. I can put parentheses if I want to, if you want to. We don't need to. Plus k. Well, I know that when I plug in k in for the x's, that's what this is telling me. When you plug in k for the x's, you also get k as the corresponding output. So all I need to do is just solve this equation, right? I just plug that in there. So I'm going to go through and do 3k squared minus 4k equals k. Now I just got to solve for k in this instance. That's what's fun to find out. Find the k value that makes this true. So if I were to go through and subtract the k, right, I got a quadratic, so get it all on one side. Minus 5k is equal to 0. All right. So I want to go through and solve this. Now, the inclination for some of you is, well, we're just going to divide by k. Don't do that because sometimes you lose possible solutions. The correct thing is to instead factor out. So if I take out a k from both parts, I have 3k minus 5. That equals 0. So I know that my 2 possible solutions are k is 0. And if I were to solve that, I would get 5/3. Now you have to look carefully. Sometimes it doesn't specify. It just says find the number k, and you would need to have both of those answers. But in this instance, it wants the non-zero number. So we're not going to have that 0 in there. And so in this case, 5/3 is the only solution. But I have seen problems where they do not have that stipulation, and you must put both answers. And if you divided by k, you never divide by a variable, but if you did being silly, then what happens is you wouldn't have got that 0 when on a future problem you might need the 0. Okay? So just be careful. All right, last one we got here. All right, we got Tim McGraw's average ticket sale prices are determined. They give us a function in there, okay, using that information. So when you look at this, the P, right, when you look at this carefully, okay, are determined the number of seats available in the venue using the following function. In this instance, P represents the price. So P is the price. Because that depends on, that's going to be our output when the number of seats, so N is the number of seats. So that's our input. Okay, so that's what we're looking at here. Okay, so the marketing team wants to keep prices around $30 to maximize profit. All right, so we got to look at is we know what N is, right? This is an N, this is an N, and this is an N. Okay, so what I want to do is I want to find out for the United Center, I want to find out what it is the price if I were to have 23,500 seats. Now, this is where your calculator is actually pretty sweet on this. You could go through and go to the main menu and just start typing in 23,500 into that equation. And you could do that, but the problem is you're going to do it 3 different times. To me, that would take a lot of time and energy. Let's shortcut this a little bit. And I love this. This is a cool function I found on the calculator. Go to y equals. Let's get rid of that guy. I guess I could have kept him because we've got a fraction here. Or actually, I'm going to do 25 plus. Let's get crazy here. Alpha y equals. You got these shortcut commands if you didn't know that. If you hit alpha y equals, it gives you that fraction. All I'm going to do is just type that in. So I'm going to say 400,000. Right? They got enough zeros. 1, 2, 3, 4, 5. Good. Hit the down arrow to get to the bottom of the fraction. And I'm just going to type in 2. Now, we can't. I'm not going to type in n because on this screen I got to make it an x. So because it needs the independent variable as an x. Minus 10,000. Okay, so all I did, and I just hit enter, and all I did, so there's my equation, 25 plus 400,000 divided by 2x minus 10,000. That's the equation I want to use. Now, here's what's kind of cool, is I want to find out what is the price that I would have to do for United Center if it was holds 23,500 people based on this equation. So if I go to the main screen, second quit, right about the top there, second quit, I go to the blank screen, all right? Now, this was kind of cool. If you hit alpha trace. It's alpha trace. I love these shortcut commands. It's actually pretty cool. If you practice your calculator, you'd find out. You practice things with your calculator, you get a million more options than your phone. You'd be like, oh, you are a superstar. So what I want to do is, this is the equation that I put as my y1. So I'm going to choose y1. So I just did alpha trace, and that I picked the first option because my equation's in y1. Now, I can use my function notation information, and I can say I want to take y1 parenthesis of 23,500. Close your parenthesis. Now, if I hit enter, it does a nice job, and it will plug that in there for me. Now, the only problem is it's giving me a fraction because I put a fraction in there. So what I probably should do is, I think if I hit, let's see, if I hit second enter, let's see, second enter, it's giving me that part instead. So what I would need to do is this. So, you know what? I had all that fun going in there. I'm actually going to fix something. I mean, you could actually go through and just type in 1325 divided by 37. All right. Or, yeah, so that'll give me the value that I get there is 35.81. I was going to go with the 3 decimals, 811. So what they're saying is my ticket prices would be $35.81 in order if I use that equation that they're giving me there. Okay. Now, if I were to do Wrigley Field, same idea. I'm going to use P of, now I'm going to use that number instead, 41,649. Now, this was pretty cool is, I also teach calculus. One thing that they use, the College Board allows, that if you have the equation already stated, you don't need to show that you're plugging in that number in the equation. If you show great function notation that you're plugging in 41,649, they know the equation that you're using because you stated up there, just showing great notation that I can go back here and I can just do on my calculator, alpha trace, and I'm going to type in, I want to pick y1 of 41,649. And if I hit enter on there, it gives me the decimal value. So it must have been that first one, must have been interesting because it was a nice number. They just did that for me. So if I just hit enter, it gives me the decimal approximation of $31. And we're talking about money, but it's okay. We'll write out 3 decimal places. So we have $31.46 is what the price would be. One more time, we want to do Soldiers Field. So P of 61,500. So if I go to my calculator again, the nice thing, I've typed the equation as y1. You have to put the P equation as y1. So I'm just going to go do alpha trace, choose y1 of, I'm doing great function notation, 61,500. Now, I believe if I hit enter, it's probably going to give me that fraction again. It did. So what I believe you can do is if you hit alpha enter, I didn't do it. Okay, I guess I got to type it in. 3225 divided by 113. These newer calculators, they give you that. The older ones, the regular T84s, they would just give you the decimal approximation. But sometimes the shortcuts are nice. All right, $25 and five. It would be, oops, got to round carefully. So 540. So obviously, which of these venue would be the best for the tour? The one that's closest to $30. That's what they're hoping for. So we are going to say good old Wrigley Field. Go Cubs, go. All right. Hopefully day one was okay. If you got any questions, please ask your teacher. All right, good luck.